Okay, in this the application of integrals. Before going through this chapter, you should know how to do integration from your chapter 7. This integral chapter, you should know the various integration rules and how to do the integration. Here, areas of various shapes like circle, how to find the area of a circle, triangle, ellipse, etc., trapezium, etc., various shapes. Add and subtract areas to find the required area. So why we need integration to find the, so we have to find the area under the curve. Okay, suppose we want to find area under this curve from this limit x equal to a to x equal to b. So this curve, this here shadowed area, we have to find the area of the shadowed region. So you have to make a rectangle like this, smaller strips. Okay, this is called vertical strip. Okay, this height y and the width is dx. Okay, this is small width dx. So this area, whole shaded area, is divided into infinite number. Okay, so some very large number. Okay, large number of these smaller strips. So now we have to find the area of this one strip. Then if you integrate over this period, you will get the complete area. Okay, we can think of area under the curve as composed of large number of very thin vertical strip like this, large number of vertical strip. Okay, so if we will take a large number, then here it will look like a rectangle. Here it is not perfectly rectangle, but if you divide this curve into large number of area, then you will get a perfect rectangle. So the area of the rectangle is length into with the length y and this with dx. Okay, that area is called elementary area. This one area, this smaller or this small one, is called elementary area. So we have to add so many elementary areas to find the area of the shadowed region, adding up all the elementary areas. So that is a vertical strip. Same thing can be done with the horizontal strip also, like this. So here you see there y dx, but here x dy. Okay, here dy is very small, x is there, dx is very small, and y is the height. So the height into width. Okay, y dx. So here x dy within that limits. Okay, y equal to the c to d. See, if you take this y dx, so x limit we are applying a to b. Here x limit, x equal to a dx. Okay, but here we are taking dy, so we are applying y limit c to d, horizontal strips. This is the elementary area here. So what happens, this is in one side only. What happens if you get a negative side like this, then you have to take the modulus. So area can't be negative, so you have to apply the modulus here. Okay, so if you see some example with something part is above x-axis, some part is below x-axis. Okay, this is below x-axis, this is above x-axis. So negative thing we are applying modulus. This, for this we are applying modulus, for this we are taking as it is. So now find the area enclosed by the circle. Okay, see, read the question properly. Find the area enclosed by the circle. So this circle, they are asking the area of the complete circle. So not only the shadowed region, the shadowed region for the only for some interpretation purpose, because this is symmetrical. This shadowed region is this side also same, this side also same, symmetrical. Okay, so we are taking the area of this one side, this one quadrant only, and multiplying it by 4. 1 2 3 4. Okay, same area. Okay, so although it is negative, then we will be taking the modulus, so only it will come positive. Okay, now so here we are taking the vertical strip. So y dx is the area, limit, okay, 0 to a, x limit we are dx, okay, y dx is changing, so we are applying x limit, x 0 to a, okay, then integrating the same area we are multiplying by 4, because 1 2 3 4, okay, then total area will come. They are asking find the area enclosed by the circle, okay, whole circle they are asking. Okay, now for the y, from this formula, y square equal to a square minus x square, y equal to square root of a square minus x square. Now that is why I said you should know the integration first. So how to integrate this, then you will refer to the chapter page 42 43. So here you see the similar thing is given, integration there without limit they are given this integration. The how, what is the result of integration, you go through this, then finally you will get this. Okay, this one. Okay, yes, okay, this is the after integration, here without limit, but there we have with limit, but this answer will be same without constant. Okay, this answer we have to apply limits there. Okay, so how to integrate it, you should refer to the chapter 7. Okay, so now see the without limit, so now we have to apply limits here, 0 to a, other things are same, then after applying limits you will get this. So same thing can be achieved with horizontal strips. Okay, here dy, okay, dy, then y limit apply, we have to apply here also 0 to a, that limit. Okay, same thing will come, same answer will come. So here we have to find the ellipse. Okay, so here also it is symmetrical about x-axis, y-axis, all the four things similar area. So here also we are multiplying with 4. Okay, then from that given formula you are arriving, then how to integrate this, then again you refer to the chapter 7. Okay, so here we are taking the horizontal strip. So here area of the region bounded by the curve and the line. Okay, this is a parabola curve and this is the line. So between this line and this curve we have to find this area. So here this area is same as this area, so we have to multiply by 2. Okay, this area and this area is same, so we are multiplying by 2. X dy, but x square equal to y, so two similar areas here. X dy, so x equal to square root of y. Okay, square root of y. So then how to integrate this, you should refer to the again chapter 7. Then after that you apply these limits. You can use with the vertical strips. Here we are used horizontal strip, here we are using the vertical strip. So till this time we have shown both horizontal and vertical strip. Here onwards we will be using vertical strips only. Preferably we want to use the vertical strip. Okay, here we are going to add the area of the two elements. Okay, here we have to find the this area. So here OBMO, this is a triangle and this is the another area. Okay, here this area of a triangle and this is, so we are adding the area of the region OBMO, this region, plus area of the region BMAB, okay, this region. So we are going to add both the areas here. So from these limits, so y dx equal to x dy, because y equal to x, okay, y dx equal to x dx, because y equal to x based on this. Then you apply limits. Similarly, this you apply limits, okay. Two from this equation, okay, y equal to, you find the area enclosed by the ellipse, ordinate x equal to 0 and x between these, okay. Here we have this region as well as this region, because this line is from here to here, okay. These two regions are same, so we are multiplying by 2. These are the limits. Again you integrate it, okay. So try to do all the problems, but at least try the some of the things I mentioned with various shapes, okay. Area between the two curves, we are taking two curves, okay, two curves f of x and g of x. We have to find the area between them, okay. We have to, here we have to subtract the areas, okay. This one curve f of x and this is g of x, then from f of x minus g of x will give this area, f of x minus g of x, okay. So we are taking the modulus, area is can't be negative. So here how they are computing the final area. See how you find here, find the area of the region bounded by the two parabolas. This is one parabola, and how you find the intersection, you assume for substitute for x equal to 0, you get y equal to 0, x equal to 1, y equal to 1. So these two intersection points you can find out. So here find the area lying above the x-axis and included between the circle and the parabola, okay. Parabola here circle one quadrant will come, but here we have to subtract this area from the circle area. So y square equal to 4x, x square plus y square equal to 8x. This y square equal to 4x, you substitute this instead of this y square, so you will get this. So this is how they compute the final area. Area of the OCPO, that is the curve, parabola, plus area of the PCQP, okay. This is the there is no parabola here. Here only parabola and circle. This is for the parabola, this is for the circle. From the above given this parabola and circle, from this equation they arrived y equal to square 2 square root of x, 2 square root of x for the parabola. The chord, the AB, this is the chord, okay, from here to here. Find the area between the arc, this is the arc and this is the chord, so we have to find the area here, this area. So here for the convenience they are dividing by 36. From this given equation, divided by 36, it will become 1 year, okay. X square, this will come. That is for finding, to find the solution, that for our convenience they are dividing, and then how they are using, you can go through it. So here we are adding, subtracting some areas. Using the integration, find the area of the region bounded by the triangle whose vertices. Okay, these are verticals. You see here, this is a rectangle ADB. Okay, sorry, this is a triangle ADB plus this is a trapezium. Okay, BD is a trapezium. Then this area we have to subtract. This is the triangle area ACE. ACAEC or ACE, this triangle we are subtracting. Okay, we are adding up this triangle plus trapezium area and subtracting this area, then only you will get this shadowed area. Okay, so here okay, first thing is based on the given problem you arrived at the integration, then you have to apply the rules from your chapter 7 to find the result of this integration, then apply limits. Okay, chapter 7 is important. Find the area enclosed, okay, between these two circles. So if you substitute for the x value, for x equal to 1, okay, x equal to 1, y equal to plus or minus root 3. Okay, from this if you substitute x, then you will get y. Okay, plus or minus root 3, it can be plus root 3 or minus root 3. Okay, these 2 points, 1 root 3, 1 minus root 3. Okay, so now you see here this curve has a separate formula and this curve has a separate formula. Okay, area ODAO, ODAO. Okay, these two areas are same. DCAD, DCAD, DCAD. So this curve is different and this curve is different. Okay, different formula. This is y dx. DCAD ODAO. DCAD ODAO. Okay, this curve is different and this is different. Limits, different limits. Okay, so this is different limits and y dx from this limit to this limit. Second is circle arc. This is the second circle. This for this. This is first 4 minus x square. Okay, from this first circle. 0 to 1, 1 to 2. 0 to 1, 1 to 2. Okay, because these two are having different formulas. Okay, after that you will get this. See, this miscellaneous also you can go through. Okay, so at minimum whatever the solved problem is there, it should be thorough. Then after that these things you can try out. This summary is important. If you don't have time go through full thing, at least summary should go through it. This is the summary. Historical notes. Okay.